Bismillahirrahmanirrahim. Assalamu alaikum, dear 8th class. Welcome to the next lecture of physics. Hopefully, you have understood yesterday's lecture very well. Today, we will continue with the same topic almost, but today, the equation of motion that we will derive is called third equation of motion. This equation of motion is also derived with the help of graphical method, and it will also make use of the same graph. So again, let us revise that how we will draw the graph for the third equation of motion. Dear students, when we have to derive the different equations of motion, we will use the graphical method. In order to use the graphical method, we have to draw a graph between velocity and time. One important thing that you must remember is this, that the body which we are considering is moving in a straight line. When a body moves in a straight line, speed and velocity both means the same. In this case, we will be considering a body which was at the start of observation moving with initial velocity vi, and after time t it started to move with the velocity vf. So during this time of observation, the velocity of the body has increased. This change in velocity, the acceleration of the body, and time, they are all related together through different equations of motion. Today I will be deriving the second equation of motion for you people, but before you start the derivation, you must learn one thing. This is a graphical derivation. A graphical derivation means that we will use this graph, which you can see in the picture, to calculate the relationship between the different parameters of motion. In this particular case, which is that of second equation of motion, I am going to derive the formula for the distance traveled by the body. Now, as you know from the previous lectures, if you have a speed time graph, then the curve over here is this AB. The area under the curve, this whole area, this will give us the distance traveled by the body. As you can see from the picture, this whole area between the points AB, the line AB is the actual graph, and this is the area which is under the graph. This whole area will be shaded. But bachcho, before I proceed with the derivation, the first step is you must learn how to draw this graph on your paper. In order to teach you that drawing of the graph, I will first go for a Bismillahirrahmanirrahim. Today we are going to derive the second equation of motion with the help of graph. As I told you earlier, the first step to start the derivation is that you must know how to draw the graph. Although I will teach you derivation with the help of the picture that is inside your book, but right now I will tell you that what are the steps that you will follow to draw the graph on your paper. The first step is that you will draw a horizontal line like this. The horizontal line that you will draw will be showing the time axis, and the time measured, or the unit of measurement for this axis, will be the system international unit, that is second. The next step is that you have to draw the speed axis, that is in this particular direction perpendicular to your previous time axis. Now I have drawn this vertical axis. You can also say this speed axis or velocity axis, as the body for which we are deriving this equation of motion, we consider that the body is moving in a straight line. If the body is moving in a straight line, then dear students, you can use the word speed and velocity interchangeably. It means if doesn't matter, either you say it as axis or a velocity axis, both means the same. The next step is on this speed axis, at any point other than the origin, somewhere over here, you have to mark a point A. As you can see now, I have marked the point A, so you have to do it on your paper as well. The next step is you have to mark another point B in this region, and that point B should be higher than the point A. So I'm going to mark the point B, which should be higher than the point A. Now you can see that I've drawn the point B. The next step is we have to join point A and B with the help of scale. Now AB is the required graph, but we have to do some further steps at this point. Let me make one thing clear. What is the point A? A is the point at which our observation started, and this is the point where the body was moving with initial velocity vi. So it means that AO distance is equal to Vi. Vi means any general value, like it can be 5 meter per second, 10 meter per second, 2000 meter per second, whatsoever was the velocity that with the help of which the body was moving. Now let's come to the point B. Point B shows the point after some time t, and at this point the velocity has increased from vi and now it has become vf. So the next step is we have to join point B with the time axis. How I will do this? I will draw a straight line and that will be dotted, and I will join it to the time axis. Now when I joined point B with the time axis, the graph has come to this point. Now this total length BD is equal to VF. Now I have written those at side. O is equal to VI and BD is equal to VF. Why I am making these things clear to you? Because these will be used later in the derivation. And now the next step that we will do is we have to shade this whole diagram OABD with the help of pencil. You have to do the shading with the light hand. It should not be that much dark that it overcomes the actual diagram. Okay. जी बच्चों, I have shaded this diagram OABD, and I have done a very light hand shading. Do not do it dark. I repeat my instructions बच्चों. If you will do this shading dark, that will create a very bad impact, and that will be very difficult for you to understand it later. Now this till this point everything is clear. One thing was left, that is, what is this OD? This OD is the time that is taken by the body to change its velocity from vi to vf. As this is a general equation, so I cannot say that what is the value of time, that either 5 second, 10 second, 20 seconds, whatsoever. Instead of making it a specific with any number, I will say that from the for the body to increase its velocity from vi to vf, it will take any time t. So now I have marked this side OD as t as well. Till this point, hopefully you have understood all the parameters, because if you want to practice this derivation very well, you have to understand each and every step and make it clear in your mind. If you have any problem on any of the steps up till now, you can ask your question in the query session. अच्छा बच्चों, if you look at this particular diagram OABD, according to its dimension, this is a trapezium. What is a trapezium? Trapezium is a diagram that is having two sides parallel, and two sides not parallel to each other. I repeat my words. What is a trapezium? Trapezium is having two sides parallel, like OA and BD are parallel over here, and two sides are not parallel to each other. AB and OD are not parallel to each other. So over here I can say that this is a trapezium. Now what is the formula for the area of trapezium? Area of trapezium is 1 by 2 sum of the parallel sides multiplied by height of the trapezium. For this trapezium OABD, the height is this OD. So I will be doing the derivation on the slide which is coming next, and hopefully you have understood all the parameters very well. Uh,
Bismillahirrahmanirrahim. This is the derivation portion, bachcho. As I told you earlier that in the figure OABD is a trapezium and the total distance covered by the body will be equal to area of the trapezium OABD. By definition, the formula of area of trapezium is 1 by 2 sum of parallel sides into height, where parallel sides are OA and BD and height is OD. Put the values, you will get this step. After that, what I will do, I will take the 2 that is being divided over here to the other side, and this expression will take this form. Now, we will multiply both sides by BC by OD. BC by OD is the acceleration, as you know from the derivation of equation number 1. Now, when you do this step, what will happen? 2s into BC by OD is equal to OA plus BD into OD multiplied by BC divided by OD. Now OD will get cancelled and the new form of the equation of motion will be like this. Now putting the values in the above equation, we get, first let us start from the left hand side. 2s multiplied by BC by OD. Instead of BC by OD there is acceleration. OA is VF plus BD. BD is VI, and BC, as you know from the derivation of the second equation of motion, is VF minus VI. Now in this expression on the right hand side you can apply the formula A plus B into A minus B on the expression Vf plus Vi into Vf minus Vi. Now it will turn out to be 2as equals Vf square minus Vi square. Dear students, this is the final form of third equation of motion. This formula will be used for solving many numericals, and this is it. This is the end of the lecture today. Ji bachcho, now this is your diary. You have to do question number 21 and you have to learn it and practice it very well. Assalamu alaikum.